So we've looked at creating a confidence interval when sigma is known or the population standard deviation is known. What do we do when the standard deviation is not known? And in real life, this is probably more the case where you do not know the actual standard deviation. Well, the calculation is the same. Everything we do is the same. There's one big difference. And instead of using z, we use what's called t. And the t distribution is very similar. The number will be sort of the same. It'll be a little bit different. And the only real difference when you create it is degrees of freedom. Now, degrees of freedom basically take the sample size into consideration for the distribution of the bell curve. So if you look here, what you have is you can see the one that's kind of the higher peak is your standard normal distribution. That's what you use with z-scores. Well, when you have a smaller sample size, for example, of 20 or 21, degrees of freedom would be 20, you would have more of a smooth or wider distribution because your data probably varies a little bit more. Where a standard normal distribution kind of assumes that you have a lot of data and usually the sample sizes are a little larger. So with the t-score, what we do is just take that sample size into consideration, and it's real easy. As you'll see once I get the example going here on the board. So normally, when you have under 100 degrees of freedom, you can assume that you can use t when sigma is not known. But once you get up to about 100, you'll see that the actual value of t is very similar to z. Now let's take a look at what the table looks like. And you can see I've got, love to get out my little pen here. Make it red. You can see like I've got degrees of freedom of 80, of 50, and you can see what the t-score that relates to it is. And I'll show you what it means by upper tail here in a second. But it's 1.676, and the one for a z-score would be 1.645. So it's not far off. You know, when you do a 95% confidence interval, that's when you have 0.025 in both of the tails. That's when you used 1.96 for that in the previous video. Well, if you had a degrees of freedom of 50, you would have 2.009 instead. So not a lot difference, but just enough to make it a little bit wider of a distribution. So again, the calculation, all we're doing is replacing one thing, and that's instead of z, we have t. And to calculate t, what we need is degrees of freedom. And degrees of freedom is nothing more than the sample size minus 1. So what that does is you then know which t-score to select based on degrees of freedom. Degrees of freedom is then, again, just sample size minus 1. Okay, so of course the easiest way to do this is to look at an example. And here you have a sample of 16 one-bedroom apartments. And the sample mean for that is $750 per month for rent with a sample standard deviation of 55. Now, if you were to go look for a bedroom, you know the average is $750. Well, the likelihood of you paying exactly $750 is very low. It's going to range. What's the best case scenario? What's the worst case scenario? So to me, if I'm looking for a one bedroom, I'm going to say the best case scenario is going to be the cheapest one, and the worst case scenario would be the most expensive. So what can I expect within 95% confidence interval? So let's do that here. And I think it's easier just to kind of go up to the board and take a look at what we want to do. So we've got the 750, we've got the 55, the 95% is what we want to calculate, and we have our sample size of 16. So the degrees of freedom in this case become (16 minus 1, or 15). We have a confidence interval of 95%. So let's draw out what that means. That means from here to here is 95%. 95%. So that means that 50% on this side, 50% on the other. That means this area here is 47.5%. This is 47.5%. This one tail is 0.025, and this tail is 0.025. So what does this mean? That means that in this section here is 47.5% of my data. In this section here is 45.75% of my data. In this upper tail is 2.5% of my data, and this lower tail is 2.5% of my data. So that's how it all kind of works together. So what is our t-score? You have tables that are going to be directly tied to the problems in the book, as well as they're directly in your ebook. There's also ways to do it directly in Excel. But if you get it, what you'll do is you'll go to the amount in one of those tails, which in this case, since we're doing 95%, it's 0.025. You go down to a degrees of freedom of 15. Again, it's n minus 1, and the value will be 2.131. So we can now say that our t-score in this case is 2.131. Over here, 2.131. So when we do the calculation then for our confidence interval, we're going to take t, and then we multiply that by our sample standard deviation divided by the square root of n. And when we get all of that, so now what we do is, again, the example before, we used 1.96 for z. This time we're going to use that t-score, 2.131, multiply that again by our 55 divided by the square root of 16, and that's going to be plus or minus 750. So let's see what that actually becomes.